Hello students, myself Swapnil Sir and welcome to yet another lecture series on our vector chapter. We have started complete lecture series on previous year questions from the board exam. Along with that, we are going for some of the recap in our subsequent lectures. Already we have uploaded plenty of the videos on our channel similar like this. So if you are interested to see this video on different topic, different chapter, so you do refer my playlist. Okay, in my today's video I'm gonna explain to you all first of all some of the basic concept related to the vector, and then we'll go for the previous year question solving from the vector chapter. Similar like this video I have uploaded on a pair of straight line, I have uploaded on differentiation, integration, so many other topic too. So if you wanted to see these topics, do check it out my playlist. Okay, so in my today's video, first of all we are going to understand some of the basic concept related to the vector, and at the end we move for the some of the previous year question from the board exam. Now without further ado, let's get start our today's lecture. So in our lecture, first of all, I will explain to you all some of the basic concept like a section formula for internal division, external division, cross product of the vector, dot product of the vector, with vectors and their types. Okay, so these are the major topic here in our vector chapter. Okay, which carries good marks in our board exams. Okay. So already we learned here direction cosines, direction ratios, relation between them, and one standard theorem which says that L square plus M square plus N square. Okay, which tells it state that L square plus M square plus N square which is equal to 1. Okay, so LMN is which is the designated as a cos alpha, cos beta, and cos gamma as their trigonometric ratios. Okay, so this one is our standard theorem in our vector chapter. Okay, that means cos square alpha plus cos square beta plus cos square gamma which is equal to 1. This one is our standard theorem which is very much important here in our vector chapter. Okay, so direction ratios we have learned A, B, C type of the direction ratios. We included these direction ratios for finding the angle between lines. Okay, like A upon we have learned for the first L as a up plus minus A upon under square root A square plus B square plus C square for finding the value for L. Again we consider the for finding the value of M as a B upon plus minus B upon under square root A square plus B square plus C square, and third M and N. Okay, last at the end we learn. Okay, at the end we learn here the value for N which is equal to plus minus A upon square root of A square plus B square plus C square. Okay, so this one is our required formula for finding the direction cosines. Okay, there are so many other conditions for finding the direction cosines and direction ratios. Okay, like there we can write their reciprocal, we take their ratio for finding the direction cosines and projection. Okay, so if you wanted to see these topics, do refer my previous videos. Okay, I already explained all the concepts there. Okay, in my today's lecture, first of all we go for some of the example. Now subsequent part we need to understand here dot product of the vector, cross product of the vector, section formula. Okay, now what is the section formula for our vector? It says that section formula. Okay, very much important result, section formula every year. Maybe it is a probable chances that exam question comes for your exam. Okay, so section formula. Okay, we have section formula for a two way. Okay, first we have here for internal division. For internal division, and the second for external division. Okay, section formula for internal division and external division. Okay, the section formula for internal division, it says that if the line or segment which divide our line segment is internally, like a line segment AB which gets divided by any other point by internally with the ratio as m as to n, then we consider as the section formula for internal division. And it says that mb bar plus na bar upon m plus n. Okay, as m and n are the ratio and b are the vectors, position vectors which exist there. Okay, which is for the section formula for internal division. Similar like a section formula for external division. If you have line segment AB, any point which divides our line segment AB which is externally, we consider as the external division. Okay, so external division, it says that if we have ratio m as to n and position vector a bar and b bar, we write their section formula as mb bar minus na bar upon m minus n. Okay, so section formula for internal division, we write mb bar plus na bar upon m plus n. Okay, and the section formula for external division, it says that mb bar minus na bar upon m minus n. Okay, this one is the section formula for external division. We just need to know these two conditions over here because these are the very much important here in our subsequent examples. Then after that, triple product of vector, cross product vector, okay, distance formula for the triple product, okay, that we all are going to learn once examples are coming. Okay, now what happen if I'm gonna explain all these results over here, that might be it will be confusing for you all. Okay, and I do not want to put you all right now in confusion because we want all the easy part. We have to grasp all the easy part first. Okay, and then the subsequent part, I don't think so nothing is difficult there. Okay, I don't think so is anything difficult. Okay, so I am expecting that you all have understood. Just little recap about my today's lecture. The remaining part I will explain while examples are going. Okay, now let's get start our first example. Okay, so in our first example, we have given if a line makes an angle, 90 degree, 135 degree, 45 degree with x-axis, y-axis, z-axis. Okay, what we have? We have line. We have line. Okay. We have line makes an angle. Okay, line makes an angle first with a x-axis. We have given first with x-axis. Second, we have given with y-axis. Second, we have given with y-axis, and third, we have given with z-axis. Okay, we have say line makes an angle with x-axis, y-axis, and z-axis are given. Okay, if the line which makes an angle with the x-axis which given as a 90 degree. Second, if line makes angle with a y-axis which given 135 degree. And third, if the line makes an angle with a z-axis which given 45 degree. Okay, so we have three angles given. Line makes an angle with x-axis 190 degree, with y-axis 135, and with z-axis of 45. Okay, so for applying some direction ratios, cosines, consider this first angle as alpha, consider second one as the beta, and consider third one as the gamma. Okay, so I do have here three different angles. Okay, and now what we want the direction cosines of the line. Okay, direction cosines of the line, it represent as L which is equal to cos square alpha, L square which is equal to cos square alpha, m square cos square beta, n square cos square gamma. Okay, these three are the direction cosines of the line. Okay, that means if L is equal to cos square alpha, that means we directly take L as a cos alpha. We don't have to go for finding its square. Okay, that means we write the direction cosines of the line as, let me change the color, direction. Okay, so I'm writing here direction cosines, direction cosines of the lines which makes an angle theta. Okay, which makes an angle theta. So we write it as the L which is equal to cos alpha, M which is equal to cos beta, and N which is equal to cos gamma. Now see that how easy part this one, just need to substitute the values here. Okay, we need to substitute the values here only, N which is equal to cos gamma. Okay, so we can see here we have the value for L cos alpha, M cos beta, and N which is equal to cos gamma. Okay, now substitute the value for alpha, beta, and gamma in our L, M, and N. You will get the required answer for as a direction cosines. Okay, so these three are the direction cosines. Consider this one. Okay, now put the value for L which is equal to cos alpha in alpha as a 90 degree. So first we'll get the first direction cosines. Okay, let me change the color. This one will be the best. Okay, yes. So I consider here first as a alpha as a 90 degree. Okay, alpha as a 90 degree. Then we write L which is equal to cos of alpha, means cos of 90 degree. Okay, what I have done, I just substitute the alpha as a 90 degree in our L which is equal to cos of alpha. Okay, and we know that when it comes to the part of imaginary axis like a 90 degree to 70 degree, cos always goes to 0. Okay, that means cos 90 which is a 0, that means we got the value for L which is equal to 0 here. Okay, now see that how easy to find out the first direction ratio. Okay, sorry, direction cosines. Now let's move for the second direction cosines. So using beta which is equal to 135. Okay, beta which is equal to 135 degree. Okay, using beta which is equal to 135 degree, we have to find out the value for cos beta. Okay, and we know that M which is equal to, we have cos of beta. Okay, and M which is equal to, we write cos of 135 degree. Okay, so substitute the value for beta as a 135 degree. Okay, so M which is equal to cos of 135 degree. Now we can see that here as we have standard angle 0, 30, 45, 90, 60, 180, 270, and 360. These are the standard angles that we can deal these values easily, that are the standard values. But whenever it comes as like a 135, 65, 145, okay, these are the odd angles, and whenever it comes for the odd angles, we always use allied angle for finding the value of our required odd angle. Okay, so we have cos of 135 degree. So 135 degree can be written as 90 plus something or 180 minus something. Okay, so if we take 90 plus 45, okay, so we can write 135 as a 90 plus 45. Okay, that means this is the dividation of 135 degree into the two standard angles. So 135 can be written as 90 plus 45, or 135 degree can be written as in the form of 180. So 180 minus something, so we'll get the 135. Okay, so 135 and 180 minus 45. So if we write 180 minus, if we write 180 minus 45, okay, so we'll get the 135 degree. Okay, let me write it's 180 minus 45. Yes, 180 minus 45. Okay, so you may use one of the value from here, okay, as addition or subtraction, okay, for finding the cos 135. So cos 135 degree can be written as cos of, okay, let me erase this one. Already we have written Okay, cos 135 degree can be written as cos of 90 degree plus 45 degree. Okay, so cos of 90 plus 45 degree, and by using allied angle we can say cos of a pi by 2 plus theta. Okay, that means cos of pi by 2 plus theta, that means pi by 2 plus 45 degree. And when we have cos of pi by 2 plus 45 degree, that means it goes to the second quadrant, and in our second quadrant cos always gives us negative sign. Okay, that means cos gives us here negative value, but whenever we comes for pi by 2, 3 pi by 2, cos get converted into the sine. Okay, so which is a sine of a 45 degree. Okay, which is a sine of a 45 degree. So that means our required value for m, which is equal to negative of a sine 45 degree, and we know that sine 45 which is having value 1 by root 2. Okay, that means the value for m which is equal to negative of 1 by root 2. Okay, negative of 1 by root 2. This one is our second direction cosines for our second line. Okay, now let's go for the third one. Third angle we have gamma which is equal to 45 degree. Gamma which is equal to 45 degree. Okay, now we know that we can find third as a n which is equal to cos gamma, third direction cosine as a n which is equal to cos of gamma. So n which is equal to cos of 45 degree. Okay, n which is equal to cos of 45 degree. So we write n which is equal to 1 by root 2. Okay, so this one is our required value for n which is equal to 1 by root 2. Okay, that means our required direction cosines are 0, negative of 1 by root 2 and positive of 1 by root 2. Okay, that is our required answer here. Okay, now that question asked in July 2017 board exam for 2 marks. Okay, now we can see that this option gives us our option number second. Okay, L is equal to 0, second m which is equal to negative 1 by root 2, and third n which is equal to 1 by root 2. Okay, yes, this one is our required answer. I hope you all have understood the entire solution for my example. Nothing is difficult here in this question. Okay, even after if you found anything difficult, let me know in comment section. And if you want this written notes entire solution, do check it out in my description box. You will get the complete so PDF for the entire solution. Okay, now let's move for the next example. Yes, in our next example we have given in under question the measure of acute angle between the lines. Okay, measure of acute angle given between the lines whose direction ratios are 3 to 6 minus 2 1 2. Then we want the direction ratios for these two acute angles. Okay, so question asked in March 2018 board exam for 2 marks. Okay, so let me write first of all what we have given in our question. Okay, so we have given the measure of acute angle between the lines. Okay, okay, the measure of acute angle between the lines. Okay, so we want the measure of acute angle between the lines. Okay, this one is our required claim in our example, and we have given the direction ratios for our acute angle. Okay, so what is the direction ratios? Okay, so we have given direction ratio. Okay, and the direction ratio of the line, it gives us 3 2 and 6, and next minus 2 1 2. Okay, these two are the direction ratios we have given in our example, and we want the measure of acute angle between the lines. Okay, so what we do here, first of all we consider this one a1 b1 c1 a2 b2 c2, and for finding the measure of acute angle between the line we will use one standard result for cos theta. Okay, we use one standard result for cos theta. Now let me tell you all, okay, how directly we can think about the cos theta. Now see that our all options gives us the values in the form of a cos inverse. Okay, the values in the form of a cos inverse. That means you have to use a required result as a cos theta. Okay, so if you're going to use the result for cos theta, you will get the required measure of acute angle between the line. Okay, so we know that the measure of acute angle between the line can be written as cos theta, which is equal to a1 a2 plus b1 b2 plus c1 c2. Okay, a1 a2 plus b1 b2 plus c1 c2 divided by a1 square under square root a1 square plus b1 square plus c1 square, again multiplied by next square root a2 square plus b2 square plus c2 square. Okay, so first square root a1 square plus b1 square plus c1 square multiplied by next under square root a2 square plus b2 square plus c2 square. Okay, now see that this one is our required result for finding the measure of acute angle between the line in the form of a cos theta. Okay, so there are plenty other ways, so we don't have to go for other one, because what we want in our question, we just need to focus on it. Okay, because our required answer is in the form of a cos inverse, so we cannot apply another result that can be difficult for getting the value for cos inverse. Okay, yes, now what we do, substitute the value for a1 a2 b1 b2 c1 c2 in our result. But now a1 b1 c1 we represent 3 as here, first a1, 2 a2 and 6 a3. Okay, similarly b1 b2 and b3. Okay, so a1 b1 a1 a2 a3. Okay, a1 b1 c1. Okay, let me we have here the value for a1 b1 c1. Okay, a2 b2 c2, so we don't have to go for this one. a1 b1 c1 a2 b2 c2 a3 b3 c3. Okay, write down them into the separate form. Okay, so a1, which is equal to 3, a2, not a2, you consider it as the b1, because we want the a1 b1 c1 in our formula. Okay, not a1 a2 a3. Okay, so a1 3, b1 2, c1, which is equal to 6. Okay, as we needed a1 b1 c1 in our formula, so jot it down in the form of a1 b1 c1 a2 b2 c2. Okay, then a2 minus 2 b2 1 and c2, which is equal to 2. Okay, so we have a1 b1 c1 a2 b2 c2. Now put all these values in our given result, so you will get the value for cos theta. Okay, so cos theta can be written as a1 multiplied by a2. Now see that a1 multiplied by a2, that means 3 multiplied by minus 2. Okay, so first plus b1 multiplied by b2, that means 2 multiplied by 1. Okay, this one is a1 multiplied a2, b1 multiplied by b2 plus c1 multiplied by c2, that means 6 multiplied by 2. So 6 multiplied by 2. Okay, and completely divided by under square root a1 square plus b1 square plus c1 square. Okay, so the value for a1 square plus b1 square plus c1 square, which is a 3 square plus 2 square plus 6 square. So 3 square plus 2 square plus 6 square, which is the first square root, multiplied by second square root a2 square plus b2 square plus c2 square. That means negative of a 2 square plus 1 square plus 2 square. Okay, these are the values for our required measure of acute angle between the line in the form of a cos theta. Okay, now next further let's go for the calculations. This is just a part of a calculation. So 3 2s are 6 and negative sign is there, so negative of 6 plus 2 1s are, it is remain 2, so 6 2s are again 12, completely divided by 3 square, which is a 9 plus 2 square 4, 6 square 36. Okay, let's go for the two different steps. 3 square 9 plus 2 square 4 plus 6 square 36. Okay, again multiplied by second square root, negative of a 2 square which comes 4, 1 square which gives us 1, and 2 square which gives us 4. Okay, so next step, it comes negative of 6 plus 2. Okay, that means 12 plus 2 18, 18 minus again a 6. Okay, 18 minus 6, so we'll get here negative of 6 minus 2. So we'll negative of 6 minus 2, it gives us negative of 4 and plus 12. Okay, so 12 minus 4 which gives us 12 minus 4 which gives us 8. Okay, so this is the value 8 we have here as the part of numerator, and denominator, now see that 9 plus 4 plus 36. So 36 plus 4 40, 40 plus 9 under square root 49. So under square root 49, that means it gives us the value 7. So we'll take it later. So 4 plus 1 plus 4, that means again under square root of 9. Okay, so we get the next step as a 8 divided by 49 is having perfect square root which is a 7, and again square root of a 9, it gives us 3. Okay, so 8 divided by 7 3s are 21. Okay, so this one is the value for cos of theta. Okay, this one is the value for cos theta, which is 8 by 21. Okay, now what we want here, we want the value for we want the value for only theta. Okay, that means what we do, take the cos to other side or apply the image pre-image concept here from the function. So you will get the value for theta. So apply cos inverse to the both sides. So you will get the cos inverse of 8 by 21, which is equal to cos inverse into cos. So it gives us the only theta remain here. Okay, so our required answer, which is a cos inverse of 8 by 21, which is equal to theta. Okay, now see that our option number D, which is correct here. Question asked in March 2018 board exam for 2 marks. Okay, so nothing is difficult here, just we need to proceed with the value for cos inverse of theta. Okay, so you will get the required answer. I hope you all have understood. Now let's move for the next question. Okay, so in our next question we have given vector, 3 vectors are given and these vectors are coplanar. Okay, and already we know that if the vectors are coplanar, that means their corresponding coefficient for this vector, like a corresponding coefficient for ijk in the form of a determinant, gives us value 0. Okay, so let's go for the corresponding coefficient of these vectors. Okay, find it out in the form of determinant and we'll get the required value for a. Okay, so we have claimed here to find out the value for a. Okay, so we want the value for a here. This one is our final claim. Question asked in July 2018 board exam for 2 marks. Okay, now let's move for the solution. Okay, so we have given vector, given vectors. First consider first vector as a bar, which is equal to I cap minus 2j cap plus k cap. Okay, again b bar, next position vector, a into I cap minus 5 into j cap plus 3 into k cap. Okay, this one is the second position vector. Third position vector, c bar. Okay, I consider, just I named them as a bar, b bar, c bar. Okay, and the c bar here, 5 into I cap minus 5 into I caps minus 9 into j cap plus 4 into k cap. Okay, these three are the position vector we have given in our example, and all of them are the coplanar. Okay, if all these position vector are coplanar. Okay, so what is mean by coplanar? All those vectors are coming under same plane. Okay, or the same certain plane, we consider it as the coplanar vector. Okay, there are some other way to find out whether the vectors are coplanar or not, but here in our condition we will move through the determinant form, okay, of the coplanarity of a matrix the vector. Okay, so in our determinant, what we do, we take the coefficient for a bar, coefficient for position vector b bar, and coefficient for position vector c bar, and we prove the determinant for these three position vector gives us the value 0. Okay, Now, for when three position vectors are coplanar, then we write their determinant, or we write the A bar, B bar, vector A bar, vector B bar, vector C bar, which is equal to 0. Okay, if the vectors are coplanar. Okay. These are the condition for coplanarity of a vector. Okay, that means A bar, B bar, C bar need to be a 0. So that means the A bar, B bar, C bar, that means the determinant of the coefficient for I, J and K. Okay, so now see that first row, first entire column, it goes to the coefficient of I cap. Second entire column, it goes to the coefficient of J cap, and third entire column, it goes to the coefficient of K cap. Okay, now I cap coefficient 1, A 5. Okay, next the coefficient for J cap -2, -5, -9. Okay, and third the coefficient for K cap -1, +3, +4. Okay, and if vectors are coplanars, given position vectors are coplanar, that means we write their determinant, which is equal to 0. Okay, so let's go for finding the value of this determinant. So you will get the required value for A bar. Okay, so we have involvement of A bar here in the second row, first column. Okay, so let's go for finding the 3 by 3 determinant. So while we are finding the 3 by 3 determinant, we have to convert it into the 2 by 2 determinant, then at the end proceed for the required solution. Okay, so 1 under bracket we write -5 multiplied by 4. So -5 4s are negative of 20, negative of negative 9 3s are 27, so it gives a positive 27. So second, negative of a -2, it gives a positive 2. Okay, so positive 2 under it remain 4 into A, so 4 into A, so that means we have to multiply both of them, minus multiply 5 3s are 15. Okay, so 4 times A it is there. Okay, 4 times A. Okay, 4 times A minus 5 3s are 15. Okay, plus into minus of 1, last 2 by 2 determinant, 5 5s are 25, so negative of 25, minus of A into 9, so plus 9 times A. Okay, this one is our expansion of our determinant, and it says that if vectors are coplanar, that means the value for our determinant gives us value 0. Okay, that means go for the further calculation, you will get the required answer. Okay, so 27, negative of 20 plus 27, so it remains positive 7 value, plus 4A minus 15 multiplied by 2. So multiply 2 under bracket, because A it is a constant, 8 is a variable, and 4 it is a constant, 15 it is a constant, so we cannot operate this calculation directly. So multiply 2 under bracket, so 2 multiplied by 4A, which gives us 8A. So negative of 2 multiplied by 15, which gives us 30. Okay, again negative of 1 multiplied by negative of 25, so which is a positive of 25. So negative of 1 multiplied by 9, positive of 9 times A, so it gives us 9 times negative of 9 times A, which is equal to 0. Okay, now go for the next calculation. So 8A minus 9A. Okay, so it gives a negative of A, 8A minus 9A, which is a negative of A. So 7 minus 30, 7 minus 30, which gives negative of 23 plus 25. Okay, negative of 23 plus 25, which is equal to 0. So I have done the subtraction between these three, and 8A minus 9. Okay, so negative of 23 plus 25, so 25 minus 23, it goes to the negative of A plus 2, which is equal to 0. So A gives us the value 2. Okay, this one is our required answer, and which given in our option number C. Question asked in July 2018 board exam for 2 marks. Okay, answer it is coming only in a 2 to 3 steps. Okay, but here for the condition of a coplanarity, we need to know here we can write that a bar, b bar, c bar, which is equal to 0. That means in the determinant of coefficient of I cap, j cap and k cap, in the form of a determinant, it gives us the value 0. Okay, and this one is the mathematical form for finding the coplanarity of vectors. Okay, let's move for the next example. Okay, in our next example, we have given if a line makes an angle alpha, beta, gamma with a coordinate axis. Okay, what we have, a line, we have given line makes an angle, if line makes an angle alpha, beta and gamma. Okay, if line makes an angle alpha, beta, gamma with a coordinate axis, with this one is given in our question, coordinate axis. Okay, if line makes an angle alpha, beta, gamma with a coordinate axis, then we have to find out the value for cos square alpha, sorry, sin square alpha, sin square beta, sin square gamma. Okay, so what we have claimed, sin square alpha plus sin square beta plus sin square gamma. Okay, so we want the value for sin square alpha plus sin square beta plus sin square gamma. Okay, so this is our claim. This one is our required claim. Okay, okay, so we have to prove this one, sin square alpha plus sin square beta plus sin square gamma. Okay, as we don't have any result in our vector in the form of a sin square, okay, so we always used to convert that sin square into the cos square. Okay, and we know that a result for cos square, it says that cos square alpha, it is the standard result for finding the direction cosines from our line. Okay, let me change the color. Yes, so we know that cos square alpha plus cos square beta plus cos square gamma, which is equal to 1. This one is our given standard form for finding the direction cosines of the line. Okay, for that we need to know the angle alpha, beta, gamma. Okay, so as we don't have any other given data, so we know that only the alpha, beta, gamma, okay, which angles with the coordinate axis like x axis, y axis, z axis. Okay, that means with the x axis alpha makes angle, with axis alpha is an angle there. Similarly for y axis beta, and with the z axis gamma. Okay, and we want the sin square alpha, sin square beta, sin square gamma. Okay, so only one of the step we can use here, cos square alpha, in the by using trigonometric term. So using trigonometric term, we can write cos square of theta. Okay, cos square of theta as a 1 minus sin square theta. Okay, so we can see that our sin square cos square alpha, we can take it in the form of a sin square alpha. Okay, so this one is easier to convert sin square into cos square. Okay, so just need to know the concept. Okay, yes, now what we do, convert sin square is the form of 1 minus cos square. Okay, yes, now here cos square alpha, which is equal to 1 minus sin square alpha, substitute in our given result. Okay, so cos square alpha, this is our standard result for finding direction cosines. Okay, so write this standard result in the form of sin square. Okay, cos square alpha means 1 minus sin square of alpha. Okay, plus 1 minus cos square of beta plus 1 minus cos square of gamma. Okay, which is equal to 1. So what I have done, I just replace cos square alpha as a 1 minus sin square alpha, cos square beta 1 minus sin square beta, and cos square gamma as a 1 minus cos square sin square gamma. Okay, yes, now take sin square cos square sin square alpha, not a cos square beta, it remain only the sin square. Okay, so cos square means 1 minus sin square. Okay, so this is not the cos square, it comes as the sin square. Now let me replace this value as a sin square. Yes, sin square of beta, again sin square of gamma. Okay, so now take all sin square together and the negative terms together, so we can expand this bracket as 1 minus sine square alpha plus 1 minus sine square beta plus 1 minus sine square gamma, which is equal to 1. Okay, take sine square together, remaining term together. Okay, that means 1 plus 1 plus 1, 1 plus 1 plus 1, 3 constant term together, negative sign common from sine square alpha, sine square beta, sine square gamma. Okay, okay, so we have here sine square alpha, sine square. So we can take it in the form of, I have converted this is in the form of sine square alpha, sine square beta, sine square gamma. Okay, so take plus 1 together. So I'm just operating given the standard result for direction cosines. So in order to substitute the values in our given claim. Okay, so sine square alpha, okay, sine square alpha plus sine square beta plus sine square gamma. Okay, and complete, which is having value 1. Okay, so 1 plus 1 plus 1, which is a 3, minus, okay, sine square alpha, sine square beta, sine square gamma, keep as it is. Okay, and take that one positive 1 here, so it goes to the negative 1. So plus negative 1 minus this step remain as it is, which is equal to 0. Okay, so what I have done, I kept negative of sine square alpha plus sine square beta plus sine square gamma as it is here. Okay, that positive 1 I have taken here, it goes to the negative. So 1 plus 1 plus 1, it is a 3 here. So 3 minus 1, which gives us value 2, minus under bracket it remain sine square alpha plus sine square beta plus sine square gamma. Okay, which is equal to 0. Okay, take this term to the other side, so we'll get the value for sine square alpha plus sine square beta plus sine square gamma, which is equal to that positive term to the other side, it goes to the negative, so it gives us the value 2. Okay, so this one is our required answer for our given example. Now see that how easy type of the questions are coming in your board exam. Okay, so question asked in July 2019 board exam for 2 marks. So the value for sine square alpha, sine square beta and sine square gamma, it gives us the 2. Okay, so I hope you all have understood the solution for this example. So if you are looking entire solution for this example, you may find this solution in our description box. Already PDFs are given there. Okay, so now let's move for the next example. Okay, in our next example, we have to find out the value for I dot j cross k plus j dot k cross I plus k dot I cross j. Okay, so we want the value for these three I, j, k. Okay, let me explain first of all what result are useful here for finding their values. Okay, and we know that j cross k, j bar cross k bar, okay, j bar cross j cap cross k cap. Okay, so we can write it as the I cap. Okay, this is just a basic results. Question asked in March 2020 board exam for 2 marks. Okay, so we write j cap cross k cap as a I cap. After that, k cap cross I cap as a j cap. Okay, and I cap cross j cap as a k cap. I cap cross j cap as a k cap. Okay, these are the result we have to use in our example. Okay, I j cross k, which is equal to I, k cross I, which is equal to j, and I cross j, which is equal to k. Okay, and one more result here, whenever we have I cap cross I cap together, so we write it as the value as a 1. Okay, when I cap cross I cap comes together. Okay, so this is the one more result, I cap cross, when we have I cap cross I cap, or I cap dot I cap. Okay, not a cross, because we are taking dot product between I and I. Now see that I dot another j cross k cap. Okay, so we will get the I cap dot I cap. Okay, and the dot product of these position vectors, we write I cap dot I cap is a 1. Similar like a j cap dot j cap, which is equal to 1, and k cap dot k cap, which is equal to 1. Okay, so these are the standard values we will apply in our example. Okay, so this one is for the dot product. So you will get the different result for cross product as well as dot product. Okay, now let's move for the solution. I hope you all have understood these results. Okay, so we will apply this result in our solution. Okay, this one and this one. Yes, so we have given I cap dot j cap cross k cap. Okay, I cap dot j cap cross k cap plus j cap dot k cap cross I cap. Okay, plus k cap dot I cap cross j cap. Okay, so we want the value for all these vectors here. Okay, so we know that I cap, we can keep I cap as it is here, so we cannot change the I cap. But j cap cross k cap, j cap cross k cap, it represent I cap. So I cap dot I cap plus similarly j cap keep as it is. So we are not going to change anything with that j cap. So left here k cap cross I cap. K cap cross I cap, it represent j cap. Okay, plus next k cap keep as it is. I cap cross j cap. I cap cross j cap, we write it as the k cap. Okay, k cap. So we want the value for this entire I cap dot I cap plus j cap dot j cap and k cap dot k cap. Okay, so we know that when we take same vectors like I cap dot I cap, it gives us the value 1. J cap dot j cap, it gives us the value 1, and similarly k cap dot k cap, it gives us the value 1. Okay, so our required answer, which is a 3. Now see that how easy type of the solutions are coming. Okay, but while finding the dot product and cross product, you need to identify the properties first. Okay, how we can take their multiplication. So that's it here only for this lecture, this example. Our option number D, which is a 3. Okay, which is true here. Now let's move for the next example. In our next example, we have given modulus of a bar is a 3, modulus of a b bar which is given 4, then the value of a lambda for a bar plus lambda b bar, standard form of vector, it is given. Okay, is a perpendicular to a bar minus lambda times b bar. Okay, so what we have given, modulus of a bar which is equal to 3, modulus of a b bar also given which is equal to 4. Okay, modulus of a bar given 3, modulus of a b bar given 4, then value of a lambda for which, okay, then we want the value for a lambda. Okay, we want the lambda for which we have given a vector a bar plus lambda times b bar is perpendicular. Is a perpendicular to the vector we have given, to the vector a bar minus lambda times b bar. Okay, so this vector is a perpendicular to a bar minus lambda times b bar. Okay, now we have to understand first of all, when we have the vectors perpendicular, then how we write. Okay, if the two vectors are perpendicular, then we write these two vectors a bar plus lambda b bar and a bar minus lambda b bar, their product it goes to the 0. Okay, these two vectors are perpendicular. Okay, a bar minus lambda b bar. Okay, so if vectors are perpendicular, the condition for perpendicularity, it says that we multiply a bar plus lambda times b bar to the a bar minus lambda times b bar, which gives us the value 0. Okay, now multiply these two brackets as we do in our polynomial multiplication. Okay, so first element into the entire second bracket plus second element into the entire second bracket. Okay, so a bar multiplied by a bar, that means modulus of a bar square. Okay, so a bar multiplied by a bar, we can write modulus of a bar bracket square or a bar square. Okay, okay, a bar dot a bar. So if you want this one, take one more step here, so that one this one will be the easier to you all. Okay, a bar dot a bar, just go for the multiplication of their separate variable plus a bar dot minus lambda times b bar. So minus a bar dot b bar into lambda. This is not a dot product, okay? This is just a multiplication between these two vectors, okay? So you need to understand dot product, what is mean by dot product, what is mean by cross product, and what is mean by simple multiplication, okay? These three are having a different meaning in our vector, okay? So be careful about this. Okay, now let's go for lambda b bar into a bar plus lambda times b bar into a bar, okay? So, and minus lambda times b bar into my plus lambda times b bar. So it gives a lambda square into b bar dot b bar, okay, which is equal to 0. Now see that this first middle two terms are quite opposite of each other, so we can cancel them here, okay? Take them away from here, so that get cancelled. So a bar dot a bar plus lambda times b bar dot b bar, we can write it as the modulus of a bar, okay? So a bar dot a bar means a bar dot a bar means a bar square, okay? And a bar square, it is always positive term, so I included here a bar square in the form of modulus of a bar square minus lambda square into modulus of a b bar square, which is equal to 0, okay? So what we do, take this term to the other side, we'll get the modulus of a bar square which is equal to lambda square into modulus of a b bar square, okay? So modulus of a bar square, which is equal to lambda square times lambda square into modulus of a b bar square, we found the value for our vector, okay? Now what we do, take this a bar square and b bar square to the one side, because as we have the value for modulus of a bar 3 and modulus of a b bar is a 4, so we will take it together, okay? So take lambda to the one side and another term to the one side, okay? So lambda square, which is equal to modulus of a bar square upon modulus of a b bar square, okay? Okay, modulus of a bar square upon modulus of a b bar square. So lambda square can be written as modulus of a bar square means 3 square, okay, which is a 3 square. Don't take directly their square root, because maybe the answer which will be vary as per your calculation. So don't go for directly the square root of our term, okay? So modulus of a bar square means a 3 square completely divided by modulus of a b bar square, which is a 4 square, okay? So 3 square, which is a 9, 4 square, which is a 16, okay? So lambda square, which is equal to 9 by 16, we have value here. What is the value for lambda square, which is equal to 9 by 16? Now go for finding the square root from both sides, okay? So we'll get the lambda, which is equal to plus minus 3 divided by 4, okay? Lambda, which is equal to plus minus 3 divided by 4, which is our required answer for our example, okay? Now see that how easy type of the solutions are coming in our example, okay? So it gives us the value for lambda as a plus minus 3 by 4, which is the option number B correct. Question asked in July 2022 board exam for 2 marks, okay? So I'm expecting you all have understood the solution, okay? Here we used only the one result for the perpendicular condition for the two different lines, okay? When we have two different lines are perpendicular, then we write their dot product or their multiplication, it goes to the 0, okay? So as I have written here, okay, their multiplication is a 0, and when we take the multiplication 0, we will get the value for required lambda, okay? Now let's move for the next question. Okay, so in our next question, we have given the area of a triangle with vertices, okay? That means in our triangle, area of a triangle given, okay, the area of a triangle with vertices 1 2 0 0 1 2 and 0 3 1, okay? The vertices is given. Let me write what we have given, okay? Given first vertices, consider it as the A given. First vertices, consider it as the A 1 2 0, okay? Second vertices we have given B 1 0 2, and third vertices we have given 0 3 and 1, okay? These three vertices are given in square unit, okay? These three vertices are given in square, okay? these three vertices are given in a square unit. Okay, what we have given, these three vertices are in the form of square unit. Okay, now we want here the area of a triangle. Okay, so what we can say about the area of a triangle? Okay, what we want, area of triangle. We want the area of a triangle. Okay, okay, so let's plot the figure. So if you want, you may plot the figure. Okay, and area of a triangle can be written as the base into height. Okay, 1/2 into base into height as the form of area of a triangle. Okay, now let me plot the figure. That should be the good to understand the concept. Okay, okay, so we have given three vertices. Consider this one is a triangle. Okay, A, again B, again C. Okay, so we have three vertices here, A, B, C, and we want the area of a triangle. Okay, that means consider this one is the height for our triangle. Okay, that means 1/2 times BC times 8 something vertices here. Okay, this one is our area of a triangle. Okay, okay, so I hope you all have understood how area of a triangle can be defined here. Okay, so we will apply directly the result for area of a triangle. Okay, let me change the color. Okay, area of a triangle. Okay, so we write area of a triangle as 1/2 times, okay, AB bar into AC bar. Okay, so we need to know the vertices there, A, B, C, then we write it as the 1/2 times under modulus AB bar multiplied by AC bar. Okay, this is the base into height. Okay, so consider AB bar and BC bar, one of the base and one of the height here. Okay, so plot the figure, you will get then notion for this concept. Okay, so 1/2 AB bar into AC bar. Okay, so we know that A bar, B bar, C bar, using find out the position vector for AB bar. Okay, so A bar can be written as 1 times, let me change the color. Yes. Yes. Okay, so first of all, find out the position vector which present with our vertices A. Okay, the position vector we consider it as the small a bar, which is equal to I cap plus 2 times j cap plus 0 times k cap. Okay, these three are the position vectors. Again, similarly with a B, we can write small position vector B bar exists there. Okay, so we write I cap. Okay, why I cap? Because 1 multiplied by I, it gives us I cap. Again, plus 0 multiplied by j gives us 0 into j cap plus 2 times k cap. Okay, this is the position vector B bar, and similarly position vector C bar. Okay, 0 into I cap. Okay, plus 3 into j cap plus 1 into k cap. Okay, these three are the position vector for our given vertices. Okay, now we want the AB and the AC. Okay, now in order to find out the value for AB and AC, that means we write AB bar as a position vector of a B bar minus position of a vector of A bar. Okay, for finding the value of AB bar, we use, for finding the value for AB bar, we use AB bar, which is equal to position vector of a B bar minus position vector of A bar. Okay, that means position vector of a B bar means I cap minus I cap. Okay, which gives us 0 times I cap. Okay, again similarly plus 0 times j cap minus 2 times j cap, that means it gives us 2 times j cap. Okay, plus 2 times k cap minus 0 times k cap, it gives us plus 2 times k cap. Okay, so this is the position vector for AB bar. Okay, similarly do it for AC bar. AC bar can be written as C bar minus A bar. Okay, so AC bar, line AC bar can be written as a position vector of a C bar minus position vector of A bar. Okay, and now see that position vector of a C bar minus A bar, so 0 bar minus I bar, so it gives us a negative of I cap. Okay, so 3 j cap minus 2 j cap, it gives us only j cap. Okay, and third plus 1 k cap minus 0 k cap, so it gives us plus 1 into k cap. Okay, So I got the value for EB bar into AC bar. Okay. So find out the value for EB cross AC bar. Okay. And we know that for finding the value for EB bar cross AC bar, EB bar cross AC bar can be written as EB bar cross AC bar can be written as under modulus I j k, the coefficient of EB bar. Okay, so first we write I j k. Okay, I j k, and the coefficient for EB bar, which is 0 minus 2 2. Okay, we write it is the coefficient as 0 minus 2 2, and the coefficient for AC vector AC bar minus 1 1 1. Okay, minus 1 1 1. Okay, minus 1 1 and 1. This one is the EB bar cross AC bar. Once you are going to find the value for this determinant, okay, so do find this determinant by yourself. This is the just a 3 by 3 determinant. For finding the value of this determinant, it is easier. Okay, so we write the determinant of this value as a minus 4 I cap. We write as the minus 4 times. So you just have to solve this 3 by 3 determinant. Okay, nothing it is there. Okay, so we write it as the minus 4 times I cap minus 2 times j cap minus 4 times I cap minus 2 times j cap minus 2 times k cap. Okay, this is the value for AB bar, vector AB bar cross vector AC bar. Okay, and for finding the modulus of AB bar cross AC bar, we take it as the under square root of first term square, that means a 4 square plus negative upper 2 square plus negative upper 2 square. Okay, so this one is our modulus for our term. So 4 square it is a 16 plus 4 square it is a 16 plus 4 it is a 20, 20 plus 4 24, it gives us the square root of 24. Okay, so modulus of AB bar cross AC bar can be written as under square root of 24. Okay, okay, and 20 square root of 24 can be written as 6 4s are 24. So take 6 out of square root, we will get the 2 only. Okay, 2 square root of 6. Okay, now we want the area of a triangle, that means we want the value for 1/2 on modulus of AB bar cross AC bar. We have here 2 times square root of 6. Okay, so that 2 get cancelled. We left here with the value of square root of 6. Okay, and the required answer here as option number C. Okay, I hope you all have understood the complete solution. We just have to follow the stepwise solution. Okay, what we have given, try to understand. What we have formula and what we have to deal with this formula, we need to understand. Okay, so dealing with the formula, it is easier, just need to know the some basic concept. Okay, I hope you all have understood my entire solution. Nothing is difficult here. Okay, so let's move for the next example. This one is the last example. The direction ratio of a line which is a perpendicular the line with a direction ratios of -1, 2, 2, 0, 2, 1. Okay, okay, question it is quite easier. Similar type of the question we have attempted it first. Okay, similarly we have to solve this question. Okay, now let me explain what we have given in our question. The direction ratio of the line, we have given the direction. Okay, we have given direction ratios. Okay, let me write in the simple small form DRS. Okay, the direction ratios of a line which perpendicular to the line, which perpendicular to the line. Okay, which perpendicular to the lines with a direction ratio. Okay, with direction ratios are given. Okay, which is a -1, 2 and 2, and another direction ratios which are the 0, 2, 1. Okay, so using these direction ratios, find out the direction cosines, or you may go for like A upon determinant of a BC, B1 C1, B2 C2. Okay, again B upon determinant of A1 C1, A2 C2. Again go for the determinant of C upon A1 B1, A2 B2. Okay, so find out this the value for this determinant, you will get the required answer. Okay, so we will get the required proportion for our values a1 b1 c1 a2 b2 c2. Consider it from there. Okay, I'm expecting that you all have understood all this solution. Okay, so nothing it is difficult in our solution. Okay, so even after if you found anything difficult in my today's lecture, just let me know in comment section. Okay, so do this example for your homework and tell me the answer in my comment section. Okay, quite easy solution there. A similar type of the question already we have solved. Okay, now what we learned so far in our today's lecture. Okay, so we have started with the some basic concept like direction ratios, direction cosines, okay, angle between the lines. Okay, so how can we find the angle between the lines using acute angle formula, and so many other concepts we have learned in our today's lecture. Okay, okay, so there are some values for condition for coplanarity. Okay, so we converted into the form of AB bar AC bar as a position vector. We transferred our given vector into the form of IJK. So all these concepts we have learned in our today's lecture. So in the form of a vector, dot product, cross product and multiplication, you all need to identify the difference between them. Okay, so I hope you all have understood my today's entire lecture. Even after if you found anything difficult, let me know in my comment section. I will come up with a similar video. Okay, so thank you everyone. Thank you for my today's lecture.